Here we are going to learn a new idea called relation between sets. Okay, so if A and B are two sets, a relation from A to B, what is it? It is actually a set itself. But what set? It is simply a subset of A cross B. Okay, so the neat idea here is the connection between two sets, which we may intuitively understand easily if I give an example, is also formally defined as a set. This is the big contribution of sets. It helps formalize certain things in mathematics which we could not specify clearly earlier, right? So let's take an example to understand this. So suppose, let's say set A is the set 1, 3 and 4, okay, and set B is the set 2, 5, okay. Now we know that A cross B contains all possible ordered pairs, right? So there are 3 elements here and 2 elements here. It will have 6 elements. In fact, what are all the 6 elements? 1, 2, 1, 5, 3, 2, 3, 5, 4, 2 and 4, 5. Okay, this is A cross B, we already know that. What is the relation from A to B? It is a subset of A cross B. Now this is usually denoted by the symbol R for relation. Again, one thing to keep in mind is in sets and relations, we see that the same symbol appears in multiple places with different meanings. We saw already for ordered pairs and round brackets. R could mean real numbers. R could also mean a relation. Now depending on the context where it is used, you must know what it is referring to. So suppose I say R, a relation from A to B. A arrow B means from A to B. So this R itself is a set. So this thing says R is a relation from set A to set B. So instead of saying this full sentence, we can use this notation R colon A arrow B equals, suppose I say R equals A arrow B. Let's just take 2 elements. So let's say 1, 2 and so let's say I do 4, 5. Okay. Now this is clearly a subset of A cross B. So this R, which is a subset of A cross B, is a relation from A to B. That means there is some connection between the elements of A and the elements of B. That is what relation means. Explicitly specifying what are these elements that are connected is what the relation does. Just like in sets, we can express a relation in many ways. Now what we have done is what is known as the roster form. We have listed all the elements. But we could also use the set builder form to list the elements in R. We could also say R, it's a very important idea here, contains elements A, B, that is ordered pair, such that A belongs to set A, B belongs to set B. This must be true because R must always be a subset of A cross B. But it is not the full A cross B. Not all elements in A cross B will come here. Only these 2 elements. Is there some connection we can find between these two? Like, how do we describe it in set builder form? Well, I've used something straightforward. You can see that the second element is one more than the first. So if I just say B is equal to A plus 1, it looks like this is the set builder form of the relation 1, 2, 4, 5. Okay. So now what we are saying is that if you have ordered pairs A, B such that they are related by B equals A plus 1, that's a relation. Okay. So this is the set builder form. And finally, there is a new form to describe a relation, which is if I have set A, okay, I can list the elements 1, 3 and 4, right? And I can have set B has the elements 2 and 5. Now, I know that every element in A and every element in B are not going to be part of the ordered pairs in R, only some are. So 1, 2 is there. So I can put an arrow from 1 to 2. 4, 5 is there. I can put an arrow from 4 to 5. Now, this is known as an arrow diagram. An arrow diagram from elements in A to elements in B is also a way of representing a relation. So there are 3 ways of representing a relation. But the most important thing is whatever representation you use, ultimately you have to understand that a relation is a set. It is a special set, as in it is a subset of the Cartesian product A cross B. Okay. So, but this is not the only possible relation. Suppose you have the relation instead of 1, 2 and 4, 5, suppose you have 1, 2, 3, 2 and 4, 2. Suppose you say R is 1, 2, 3, 2, 4, 2. Okay. So I'll call this R2 because this is a different relation. Maybe I'll call this R1. So R1 is what we just defined. R2 could be another relation. This is again a subset of A cross B. Now R2 we have listed in roster form. How would we list R2 in set builder form? Well, we could simply say R2 is A, B, where A belongs to A, B belongs to B. But what's the connection between A and B? Well, no connection except that B simply has to be 2. That's all. That's the connection between all of these. So let me just separate this. Right? So this is one way of showing R2. Similarly, in arrow form, if I had set A, which is 1, 3 and 4, and set B with 2 and 5, how would you show? There's an arrow from 1 to 2. There's an arrow from 3 to 2, and there's an arrow from 4 to 2. So you can see that multiple arrows can lead to one element, and I have not shown the example here. From one element you can have multiple arrows going out. Suppose 1, 5 is also part of R2. I will have an arrow going from 1 to 5 if that was a part of it. So ultimately, what is the maximum number of elements that can be there in a relation? It is the same as the number of elements in A cross B. Right? That's the maximum. And what is the minimum? The minimum is simply 0. You can say an empty relation is a relation with no elements. That's still a subset of A cross B. No arrow, no elements, right? That means it's still a valid set, right? So a relation can be from anywhere to empty to having all the elements of A cross B, in which case all the possible arrows will be there, all the possible elements will be there in the roster, and in the set builder form there will be no condition. A, B such that A belongs to A, B belongs to B, that's all, period. We don't need to add any more condition because all the elements will be there. So all of these are examples of valid relations, and these are the ways of representing the relations.